Hello students, today we will be studying how to write an assembly language program to determine the sum of elements in an array for microcontroller 8051. So, in order to determine the sum of elements in an array, first we need to know what is meant by an array. An array is a systematic arrangement of similar elements or objects. So here we are selecting the similar elements to be some numbers, that is randomly I have chosen it to be 11, 12, 13, 14 and 15. All these numbers has to be added. So once you add all these numbers, we obtain the value to be 5F. So these numbers are saved in some memory location. As you can see in this table, in 30H memory location, we are storing 11 as the number, and 31H memory location 12 is the data that we are going to save, and in 32H 13 the same way it continues till 34H and 15. So we will have to write an assembly language program to add all these numbers, and the final result what we obtain after adding this 11, 12, 13, 14 and 15, that is 5F in hexadecimal. So this value has to be stored in some other memory location which is considered to be 40H. So now, knowing this basics about the sum of elements in an array, now let us start programming. Double click on Keil Microvision 4 software which is present on the desktop. So as a first step, go to project, click on new Microvision project. So on desktop, create some folder and give your project name as array. You can give any name for your project. So I have chosen it to be array. Once you give the project name, it will ask for which type of microcontroller that you want to choose. Since we are studying Intel 8051 microcontroller, I am selecting Intel 8051AH, and you can see the description of that towards your right. So once you select 8051AH, give OK. Then it will show this message, copy the startup file. So that is not required, give no. Once this is done, as a second step, you should create a new file. Once you create a new file, in the text editor window, we need to write the programming. Since I have already written the program and copied it, let me paste the program. So this is the program to determine the sum of elements in an array. I will be explaining this program later. So once this program is written in the text editor window, go to file, click on save as, give some name to your file, array. I am giving the same array as the name .asm. You can give any name for your file, but the extension should be .asm. Once the file name is given, you save. Then you have created a new project and you have created a new file and already written the program and saved it with some name. Once these many steps are over, then we need to add this file to this project. How will we add is, go to source group icon and right click on that, so that we get this option, or add existing files to group source 1. So click on this. Once this is given, this message will appear. So what type of file we have chosen? It is ASM type of file. So click on ASM source file. Then it will show which is your file. So array.asm is the file. Select that and click on add. Once this is added, close. So click on this plus mark. You can see this array.asm. So how will you cross verify whether your file has been added to your project or not is, close this editor window and double click on array.asm. If this appears again, then it is verified that your file has been added to your project. Once this is done, go to save, then give build target. So when you click on this build target, all the errors and warnings will be checked. Since there are 0 errors, now let me go to debug and start debugging the program. So it will show this message, give OK. So while explaining, I have already told you that in 30H memory location, 30 to 34H memory location, I am giving these numbers, 11 to 15 numbers I am giving, so that in 40H memory location, I should get the result as 5F. So for that, I have written the program here. So 30 to 35H memory location, I should add the data first. For that, go to view, select memory window. So choose any one memory window. So here the address should be given as D:0x30, which means that D is the data memory. D:0x30. Give enter, which means that D is the data memory is chosen. Give colon, then 0x30 indicates that 30 is the memory location and 0x indicates it is hexadecimal value that you are going to consider. So in 30H memory location, I am storing 11. This will be 31H. I am storing 12. 32H, 13 I am storing. 33H, 14 I am storing. And in 34H, 15. This is what is the numbers I am storing. Once this is done, give save. So let us start executing this program step by step. That is, you can see here, as and when this instructions gets executed, you can see how the values are going to move into the registers. So now click on step 1 line. So when you give this, you can see this line is being executed, which means that move R1, #05H. So #05 is the immediate data which is moved to R1 register. So R1 is loaded with 05. So the next step is executed, which means that move R0, 30H. So #30H means that it is an immediate data. 30H is moved to R0. So you can see R0 is loaded with 30H. Then as a third step, it is move A, #00. So accumulator is loaded with 0 value. Next step, add A, at the rate of R0. At the rate of R0 is indirect addressing mode, which means that R0 is having 30H. At the rate means that the memory whose address is in R0. So in 30H memory location, what is the data present, that will be added with your accumulator and the result will be stored in accumulator. As you can see, A was having 0 and in 30H memory location we had the value as 11. So once it gets added up, the accumulator will be having the value to be 11 and it is shown here. So next step, when it gets executed, increment R0. R0 was initially 30H. Now once it gets incremented, +1 will be added. So 30 + 1 becomes 31H. So this 31H is loaded into R0 now. Then decrement jump no 0 R1, loop, which means that R1 is loaded with 05, which means that there are 5 numbers which we are going to add. So 05 will be decremented in this step. So it becomes 04. It will check whether it is 0 or not. So it is not 0. So that the condition is true. That is why R1 is not 0. So it goes back to this looping. Then again what happens? this looping, this steps gets executed. Add a comma at the rate of r0. So r1 is now loaded with 0, 5 because this decrement jump no 0 step says that it will be decremented. R1 value will be decremented by 1. If it is not 0, it goes back to the loop. Now this looping operation will be executed. Once this looping operation is executed, what happens is add a comma at the rate of r0. Initially a was having 11. Now at the rate of r0 means that 31. In 31 memory location 12 is there. So 12 plus 11 will be added and the result is 23 that will be stored in accumulator. Again increment r0. Once it gives increment r0, r0 value was 31. So now it becomes 32 and again it checks for decrement jump no 0 r1 comma loop. So r1 was decremented initially to 4. Now again it gets decremented to 3 and it checks whether r1 value is 0 or not. Since it is not 0, it goes back again to the loop. Then add a comma at the rate of r0. So it was having the result of these two. Now 13 will be added with accumulator value. So 23 plus 13 will be added and you get the result to be 36. Again it increments r0. r0 is incremented to 33 now. Then decrement jump no 0. r3 will be loaded with, so r1 becomes 02. So it gets decremented. Then accumulator, it gets added up with the accumulator. Whatever is the previous result, all these 3 numbers plus 14 will give you 04a. Then again decrement jump no 0 so that your r0 value is now 34. It is incremented, r0 is incremented and it again comes back to the loop and finally your complete array of elements, the result is obtained in your accumulator. So you can see in the accumulator you are obtaining the value of 5f. So once this is done, now r1 is equal to 0, that is here we are taking decrement jump no 0 r1 comma loop. So once it keeps on decrementing, initially it was 5, then it became 4, 3, 2, 1. Now it is 0. Once it is 0, r1 is 0, the condition is false, it will come out of the loop. Once it comes out of the loop, the result was in accumulator, that is the sum of the elements was stored in accumulator. That sum will be stored into 40H memory location as a final step. So sjump $ indicates the end of the program. Now you can see the result is stored in 40H memory location. Type 40H. So you can see 5F as the result. So this result is obtained by writing this assembly language program and you can verify it theoretically using your CalC. So this is how you are going to find out the sum of elements in an array using Keil Microvision 4. Thank you.
At MSR UAS, we spark your imagination unlike any other.